Hello, I am Kris. I am the lead engineer at Hutlihut Games, and together with me is Javier, who is one of our engineers. And today I'd like also to talk about basically the topic of how we had a problem with our buttons and how we went down the path of trying to come up with a simple solution for it, and how we ended up with something that then allowed us to make a lot more complicated systems down the road. But before I get into that, I want to talk about us a little bit. So we're Hutlihut, we're a company based in Copenhagen. We're made up of 16 people who are mainly just people that really like video games and sci-fi. And at Hutlihut, we work on a title called Void Crew. It is a game released into early access in September last year, and it is a up to 4-player cooperating space adventure game where you explore space, control the ship, control various systems on it, engage enemies, EVA, explore wrecks, and so on. The game is composed of 3 pillars. First one is that cooperative experience. We focus on a lot of tactical mechanics and also epic space battles. So today I'll be focusing on the tactical mechanics part of the game, which basically means the game needs to have lots of buttons and a lot of various interactions to interact with a lot of different things, which also means that a lot of things need to change. So there's fundamentals like just opening doors, activating a lot of systems on and off, but in result, that means whenever you turn something on or make some sort of interaction, there's a lot of also VFX, SFX that need to trigger, animations need to play, and so on. To do these things, we basically keep some ground rules about how we approach the actual code structure in the project. And we try to draw some hard lines between the game logic and all the game VFX, SFX, animation logic. So if a PR is made that from game logic references something within the audio, it's not probably going to go through. And that allows us to basically keep the code clean, it allows us to keep the responsibilities clean, and this also then leads into our assets as well. So we basically end up with fewer assets this way. We're not just recreating the same LED multiple times just because we're referencing different sort of a prefab within the project. And again, just more clear responsibilities, and it also incentivizes us to put more effort into those single assets. So when we create something good for one element, it's then being reused across the whole project, so it benefits just more. So with this clean separation we have, then we actually have to hook up those VFX, SFX to all those actual interactions that we do. And that is where we start encountering problems. So one leap approach that we can take is just unity events for everything. So we interacted with something, it changes the state, and we just start piling up events upon events upon events. And the result of that is that you end up creating assets where you are essentially controlling all the VFX, SFX, and whatnot within your actual prefabs and parts of your prefabs that shouldn't probably really do that. It centralizes everything as well. Chance of conflicts suddenly start emerging very much. Or what we can start doing is creating a bunch of connective tissue scripting, what I would call. So basically just writing code, various handlers, managers, and whatnot that take the certain LED or some sort of VFX, connect it to some sort of a data and whatnot. And you end up eventually with just a lot of this connective tissue scripting that at some point just becomes a bit too much effort to maintain and sustain as the project goes on for long periods of time. So we took an approach of trying to build something custom specifically for this exact use case. And the first thing we took out of this is looking at what we're actually solving. The data that changes throughout all of this is actually very, very limited. Like most of the time, it's just a single Boolean flipping on and off. Sometimes it's going to be a byte, maybe iterating from multiple states, an integer. Maybe it's flowed between, varying between different states. But still, it's usually just a single piece of data that just needs to be then at the end responsible for a lot of things actually changing in the actual game world. So from that, we can start laying out some basic requirements. So we want just some sort of a wrapper for the data that will hold it. We can then request the data to actually be changed, and we want to listen into the data. So that's the sort of a simple, naive starting point for us. So we can start drawing up some simple APIs for that. We just want to be able to get the data, listen in on any changes, request it to be changed. But of course, as the game logic grows, we need to start adding some additional requirements for it. So simple use case would be that just because I'm trying to turn on a module, the button doesn't mean it needs to do something. Maybe there are some sort of criteria within the game itself that says, okay, this item needs to be occupied or inserted into a certain socket. Maybe some sort of a gameplay mechanic elsewhere needs to be completed. So we want to be able to inject some sort of validation logic that the action you're trying to do actually goes through. And at the same time, we also want to be able to just add some boundaries to how the whole thing changes. So basically just a way to do some post-processing when the data is getting applied, and we usually refer that to the owner of the actual data. So with that, again, we can just add some simple API extensions to it to just say that, hey, you can now plug in these change validators, which will just say, is this change actually valid? And at the same time, also just do some post-processing for it. And because we are a multiplayer game, we also add a little bit of logic to kind of handle that. So just simple logic like converting 2 bytes, converting back from the bytes. And at the same time, if it's the host or the owner of the data on a different client telling you that this is the actual new state, you don't ask questions. You just switch the new data and that's it. And so just some simple API additions to it. And for the designer's point of view, what they end up with is just something what we call change responsive variable that we just wrap into Boolean, integer, or whatever other type that they can just simply declare within their code base. And then in the editor, you'll just see, okay, is this, for example, in this example, if something is on, for example, and you can just try the current value and whatnot. But this, of course, is only the actual data part of it. Then we need to actually connect to the actual data. And the most simple approach or new approach would be that maybe wrap it into some interface or whatnot. But again, that ends up kind of potentially bloating the classes that you're working with. We really only care about the actual data part of it. We don't really care about where the data is contained. So for that, we create an actual specific hook directly to the member of the class. That can just be any sort of model behavior. Most of the magic here happens in the editor to actually then extract it and serialize all the data. I won't be going for it today, but in the end, what we end up with is just something that allows us to say, within this LOD, I will say this is a member reference to of a type with entry responsible, and throughout the editor, we're then directly serializing references to these exact values. And the result of that is that in this case, what we create is just, for example, 3 switches, a bunch of lights, a bunch of environmental effects connected to a single variable. And whenever one of these switches flip, all of them are able to react to it. All the LEDs are able to switch, the fan stops turning, all because it's very centralized and simply referenced. And then designers don't have to suddenly go through hoops of setting up any sort of connective tissue. You need to necessarily deal with it. You're just able to create a standalone button, standalone LED, point to the same common point of data, and then basically end up with this result with very, very little effort. You're just able to mix and match. So this is the sort of the basic what we built up, but then we ended up going forward to try and build more complicated systems out of it, because it ended up just being that easy to work with. And how we'll take a word for that, about what we actually ended up using this for after the initial demos were built. So there you go.
Thank you very much, Kris Jonas. That should be fine. So, as he said, we now have a designer-friendly and editor-friendly tool that allows us to connect the effects of an interaction of a button to the button itself. But we quickly realized that the solution that we had built actually did not stop there. It also allowed us to connect data with data. And what that means basically is unite or connect gameplay systems together. That is tremendously powerful. And we believe that the reason why we managed to achieve these things that I will show you in a moment is because of how we developed all these tools with the idea in mind of creating not tightly packed and tightly connected systems. Basically, we had a problem, a as Kris has defined. And instead of creating a solution that only solved that problem, it was a solution that had made sense on its whole, and it had a reason for existing on its own. Now, what have we made out of this? Let's start with the power system. The power system is present almost all throughout Void Crew, and we begin with the ship's power system. So basically all players have a player ship where they play, and the very first example that we encounter of the power system is just turning modules on and off. A module is just a part of the ship that you can build. Maybe you can build a weapon or a shield system. You have to power that on. When you do that, you're connecting to the ship's central power system. And here we can already start seeing these change responses that Kris has mentioned before. For example, in the circuit breakers. They act like power fuses in real life, basically, and if one of them breaks, you will need to go and repair it. Because if you don't, and you run out of them, the next system, which is the central computer, will break. And if that little baby in a capsule that we have in there flops, your whole power goes off. That's a problem. If you're fighting, 20 enemies and your power goes off in your ship, you are in massive danger. So it's at all costs something that players need to avoid. And as you can see, that's already gameplay that is being defined due to some references that have been set in editor using this new custom system. The power breakers can't flip. If they flip, they need to be turned back on. As you can see, that's just 2 states. And if they don't, the baby can fall. We don't want that. However, the power system, and again, let's only remember one system, it doesn't stop in the player ship. Throughout our game, the universe is populated by space stations, what we call wrecks, and they can also feature power system inside of it. So imagine how you visit a station that is completely dark, and you just can go in there and actually turn on the lights, turn on the doors, make everything come out to life, basically. Here in the GIF, you see an example of that, where players have picked up some power fuses, inserted them into the fuse containers, and that makes the lights turn on, and many other things like getting to loot hidden behind automated doors, or maybe getting access to a weapon that will help you defend your ships from outside your ship, which is insanely valuable in our game. This is how the structure of the power system looks. It's mainly composed of these 4 entities. So the power system itself, like the core of the system, propagators, which we think of as cables, basically, that connect the system to the different users of the system. Providers, which are more like power generators, so some things that can add to the total amount of power in a system. Like, for example, in the player ship, you can install power generators. And perhaps most importantly, drains. Drains is what we have here in the floor, in the roof, for example. Anything that uses power to work, or at least needs to be connected to an active power source. We have a hierarchy over there, not so important because we're gonna just look it in a graph. We have a button on the top right that players can interact with. That button, all it does is turn on the little power system marked in yellow. However, that has massive implications. In this super simple system, it just gives power to the propagator, to our cable, which takes the power to our LEDs, and they turn on. Super simple. That's basically what Kris was talking about before. But how about we actually expand the system a little bit? Let's just give it, for now, a very simple connection of a power generator that gives power to a secondary power system. And that power system sees that it has received power, so then it can turn on. Now we have 2 power systems, but it feels a bit, not complete yet. And that's because that's where our actual rec generation system, for example, kicks in. And our designers can set a wide array of possibilities of, I want this possibility to spawn, or perhaps I prefer this other possibility. Then our system kicks in, decides which one will actually be spawned, and hooks it up dynamically. That's why that arrow over there is dotted. Any cable, any propagator, can connect to any power system in runtime, which is completely made easy with our new member references that Kris was talking about. And as you can see, that means that turning a single button on, it turns 2 systems on and 5 LEDs on, as an example. Those could be doors, those could be weapons, it could be any drain. There are other systems, however, in play, not only the power system. For example, the core priority selector. That's a system in the game that allows you to choose what you emphasize or like make your main focus in your ship. Is it power? Is it damage? Is it speed? There are three options, so a bool doesn't work anymore, and that's where the change responsive bytes, for example, come into play, that give you many more options to configure, as Kris was mentioning before. We also have enhancements. Enhancements are mini games that you find in many modules, and when you play with them, you can get the module to an upgraded and enhanced state. That can be either enhanced and not enhanced, which, as you can imagine, we would just use a bool, or it can be graded, as you can see there in the clip, and there it will be a byte or an int. And lastly, like the star of the show in terms of systems, comes the logic gates. Logic gates are a very widespread term, but it's our own custom tool also that we are building here. And what they allow us to is to have more than one change responsive bool, in this case, that interacts with each other. In this example, we have two terminals that two players need to interact with at the same time to generate a single result, which is opening a door. So as you can see, it's two separate interactions that get converted or united into one. And that's what a logic gate of type AND achieves. The key, this is not a new term by any means, basically, but the key is how we have solved them. And this might already feel familiar because we're using exactly the same tech as Kris Jonas has been explaining before. These are also member references. These also ensure that we don't couple gameplay logic with the results of it. And it's just basically a super scalable system that allows our designers to create many varied things very quickly. And lastly, with these logic gates comes the future of Void Crew. Void Crew is still in early access, but we want to create many more puzzles and many more regs. And logic gates really enable that functionality. For example, and this comes directly from our designers, one thing that the type of puzzle that they're thinking about involves keycards. We have an item system in our game where a player can carry a system. What about if you can carry a keycard? That means that I can then go and interact with a keycard reader, which of course, and I hope you expect by now, will need power. And if it is powered, that might already activate a bool or a state, okay. But how about do you need multiple readers to kick in at the same time? Well, then we have to use logic gates, right? And how about they get disabled after a few seconds? Well, that already enables a lot of gameplay, like having to swipe on keycard, throw it to your friend picks it up, also swipes it, and if you're quick enough, you can then get access to the cool shiny loot or the amazing weapon hidden behind the powered door. And yeah, that's been it from us. Thank you very much. We hope that you have an amazing event, and of course come by the Indie Showcase to talk to us. We're in the stand B, and we'll be happy to chat with you all, amazing people. And if you have any questions, just send it our way now.
Questions? All right then.
Thank you.
Right.
Oh.
Just curious, do you have an example of one complex system that you've made and that you're really proud of using this?
Yeah, so actually right now we are rebuilding the technology that we use for spawning the regs, and that's why the dynamic hookups came into play, and they were shown here, because they were never meant to be dynamically hooked. I mean, we could imagine, we could envision, and that's part of the key, as you can explain right now, because you're the master of that, basically, of trying to think ahead, basically. We never thought of that particular possibility, but your way of designing the system, which is his idea, allowed that to be the case.
Yeah, as you mentioned, it's basically just Rex will probably be the next big iteration where these things are the most powerful. So just a lot of procedural puzzles, a lot of procedural challenges that we're trying now to build up. As for what exists right now, so probably Power System is the one that uses it the most. Otherwise, we also have already existing quite a few puzzles that use this quite a bit. Yes?
I have a really stupid question. What's the story behind the name Hutlihut?
Benjamin?
yeah, Hutlihut was like, it's a like part of Danish culture basically, because it was a chant in a football game, as far as I understand, from a commentator. So from there and from the fun of it, it came the idea to call the business Hutlihut Games, when our creative director was joining up with our business director as well, and creating the company in the first place.
Yeah, because I remember like one of the key things that got us named is basically, it's a word you say when you're just happy and excited. Hutlihut.
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 Thank you so much, Cristiano.